S-Chan presents Educational Video Lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, today we are going to study about the IC 555 timing circuits. As the name suggests, IC, it is an integrated circuit. How we make the integrated circuit, what are the essential components of the circuit, how we count the number of legs with the integrated circuit, and how the applications are generally used.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
My name is Kanhaiya Jha and welcome to the S-Chan Academy. In the beginning, we have learned about the small components like PN junction diode, then transistors, then the bijunction transistor, then the MOSFET. So in this, we learned that how after using the operational amplifier, how we make this timer circuit IC 555, and we will learn how to calculate the number of legs also. If you see, we are going to learn about the pin configuration, that how we learn about the number of legs which are generally used in the particular integrated circuit. What is the purpose of this particular pin? How we are using the reset pin, how we are using the input, how we are using the output, how the different pins are generally used. Then yes, the integrated circuit of the 555, that one is a IC circuit that we make a block diagram, and one is a integrated circuit. In the integrated circuit, how we are using the different op-amp in a different part, and how we are coming from the input to the output. They are used on the three basic mode. One is a bistable mode, one is a monostable mode, and one is a stable mode. So we will rotate the IC 555 on these bistable, monostable, and stable. Yes, then we will learn what is the application of the IC. I hope we all are aware that nowadays we are moving digital. For example, the mobile phone we are using is a digital, the laptop is a digital, even the watch that we wear nowadays, that is a digital. So everything is a digital because of the accurate output. We are using everything digital. So this machine will make the things digital. This is basically the time delay circuits. And the time delay, you can see that varies from the microseconds to the hours. So the IC 555 can generate the signals which has a time delay which ranges from the microsecond. You can see that how less it is, and ranges to hours how big it is. So you can see this. The input voltage requirements for this particular voltage are from the 5 volt to the 18 volt. From 5 volt is basically a knee voltage. Below that, it will not show you the linear thing, and 18 will become the saturated. So the basic requirement will be from the 5 volt to the 18 volt. Then we can see this particular pin configuration, but before the pin configuration, let us learn that how we are going to make a calculation of the number of legs with a particular integrated circuit. That whenever we are making any particular integrated circuit, then on the given particular integrated circuit, how we are going to calculate the number of legs. So let's calculate that first. So here we are making a circuit, the integrated circuit. Okay, and I just tell you that how the integrated circuits are made. When we club the small components, okay, for example, if you are aware of a very basic circuit, IC 741 you have made, okay. So in those we generally club the NAND gates and make. So here every IC has a curved portion. Here the curved portion is like this. So whenever there is a curved portion, then we are calculating the number of legs from here. So it has 8 legs. So 1, 2, 3, 4, 5, 6, 7, 8. So we can say that after the curved portion, we'll start the calculation, and below the curved portion, starting the calculation in the sense that we will see that what is in the gate leg 1, what is in leg 2, what is in the leg 3, what is in the leg 4, and then leg 5, leg 6, leg 7, and then leg 8. So this is basically what we need to calculate in this. Okay, so let's see that how it works. So we can see that in the leg 1, which is a grounded. Leg 1 is a grounded leg. Okay, we say that every supply has two supply, the positive supply and the negative supply. So negative supply is basically a grounded. So we can see that leg 1 is a grounded, and the leg 8 we are giving it a supply. So you can see that from the pin number 8 we are giving the supply, and the pin number 1 is grounded. Then the pin number 2 is a trigger. Then pin number 3, from here we calculate the output, and the pin number 4 is basically used to reset the particular values. Then the pin number 5 is to use to control the voltage. Pin number 6 is used for threshold. Pin number 7 is used to discharge. So we can see that there are 8 pin. As usual, pin number 1 is a grounded, the pin number 8 is used to give supply. Pin number 2 is basically a trigger. Pin number 3 is to calculate the output. Pin number 4 to reset the particular values. And then pin number 5 is for the control value, control voltage, then for threshold, and then pin number 7 to discharge the particular voltage. So till yet what we have done is the 555 pin configuration, that how to read the different kind of pins. So we take a small break now, and after the break we will learn that what is how the different pins are generally used. Thank you.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
So welcome back, students. Now till yet what we have done was the name of the pins and how they are calculated in the IC 555. Now in this section we will study a very important concept, that what is the function of each pin, why we are using this. Because different IC, as from the requirement, they have different number of pins. So in this 555 we have already learned that there are 8 pins, and now we will study that what is the function of each pin. So let's start. The ground one, the pin number 1, which is a ground reference voltage, low volt level at a 0 volt. As we all know that when we give supply to any particular component, then there is a one positive and the one negative. So we say basically that it is like this. We say that one positive and the one negative, in the sense that one is a positive and one is a negative. So we say that it is a plus VCC and minus VCC. So we oftenly say that this is a grounded also. So when we say that the grounded, we know that it is 0 volt as a minus VCC. So the pin number 1, as we say, it is basically used for the grounding purpose. Then we have the pin 8, which is used for the positive VCC. As we have discussed that there are two things, voltage supply. One is a plus VCC and the one is the minus VCC. So this voltage, this particular leg pin number 8 will generally use for the minus VCC, plus VCC for the voltage supply, which is usually between 3 to 15 volt, depending upon the the variation, depending upon the uses and the requirement. It generally varies from the 3 volt to the 15 volt, and this is the negative VCC, this is the negative supply. Now the pin number 2 is called the trigger. The output pin goes high and the timing interval starts when this input falls below half of the particular control voltage. This is the control voltage, half of the control voltage. And then it is output approx 1.7 volt below the VCC or the ground. So when we are calculating the output from this particular pin number 3, it is approximate 1.7 volt below the VCC or the particular ground. Reset, as we say the reset, the timing interval may be reset by driving the input to the ground. It means that when we are using the 555 timer and in between you want to reset and goes to the 0, reset it, it will goes to the 0. From again 0, it will again generally start calculating. So repeating it, pin number 1 is a ground pin, pin number 2 is a trigger. Trigger, as you can see that the output pin will has a high voltage and the high time intervals, okay. And for the pin number 3, we are calculating the output, and in between this, if any variation happens and we need to reset the particular timings, then we can use the pin number 4, which is the reset pin. Then the pin number 5, it has a control access to the internal voltage driver. Okay, so it is basically used as a control access. Control access in the sense that the time variation in terms of the time or in terms of the signal which is varying in this particular circuit, it will control that particular thing. Then the timing interval when the voltage is threshold greater than the control voltage, and then the discharge of the capacitor. So discharge in the capacitor will happen when it will be used for the open mode. After that, charging will be, till yet the circuit was an active circuit, but now it needs a discharging, so it will go into discharge mode. So we learned here that how from this particular integrated circuit, we give here both the input, this is the ground and this is the plus VCC. From the ground, it is a 0 volt, and as we have discussed that this ground is a 0 volt, and this particular is ranges from 3 to 15 volt. Okay, so in between this, if there is anything which is need to be reset the value, we can do it from the pin number 4, as we have discussed. Pin number 4 is basically the reset. As you can see in the figure here also, that pin number 4 is a reset. From 3 we calculate the output. Okay, reset from 3 here we calculate the output, and the 2 is the trigger. 2 is a trigger, okay, and then we can see that here 5 is a control voltage, 6 is a threshold voltage, 7 is discharge, and 8 is the output. So in between the operation, if anything to reset the particular value, we can reset it and we can do it. Now this is the particular pin configuration. Okay, in the P configuration, we start from the ground, we go to the trigger, output, reset, then we'll study the particular discharging threshold and the control. So basically control basically, as the name says, control from the input to the output. That if something, the voltage variation going on or the signal variation going on, then it will generally have a control of the input to the output. This is the value of the control voltage. At any time, if you want to reset, suppose that we are using a clock and for a particular sports purpose and all that, sometime we need to reset the clock. Okay, in the same way, this particular timing circuit can be reset to any particular value, and when we reset to any particular value, again it will start. Discharging leg can be used when the capacitor is discharged. Again we need to charge it. Okay, so this is the particular configuration of the IC 555. The most important in this, that it works on there, you can see that the plus VCC 3 to 15 volt. If you look at the characteristics of this, okay, 5 to 18 volts. So here we can use for the transmission purpose, where the signal transmission is going on from the one particular point to the another particular point. For example, a signal has to be processed. The signal has to be processed from the point A to the point B. And suppose that we have points A, B, C, D, E. So we can see that it is going from the point A to the point B. And at any time we see that it was moving from A, B, C, D and E. At D, there was some problem with the signal and the transmission stops. So from here we can reset the particular values. From this particular D point, we can reset the particular values, and again we can come back to our original point. Control voltage will see the flow of the voltage, okay, for the entire particular integrated circuit, that how it is moving in the control voltage and all that. So basically in the coming modules when we will study, then we will study more about where this particular integrated IC 555 is generally used. Basically we use it for the multi-vibrators. We will study in the coming modules that how the multi-vibrators are used as a monostable, a stable and the bistable. We will make the circuit, we will see that how the calculations are generally done with this particular thing. So I am sure that for the IC 555 timers, the block diagram is clear, the pin configuration is clear, the function of the pin is also clear, that how we are going to use the different pins with a different function, how the reset pin is important in this, how the voltage variation from the 5 to the 18 volt, which is very important. And again a very important pin in this, that we'll study about a threshold, which is can go above the particular voltage and below the particular voltage, and then we calculate the particular output. So thank you very much.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.